Let's finish talking about solving systems. So we've learned graphing, we've learned elimination. I kind of showed you a little bit of substitution last time, but now we fully want to talk about substitution. So section 2.4 is all about substitution. After I talk about this, then I'm going to hit up the word problems with you guys, okay? Because I feel once you know the algebra, when we get to the word problems, it should be smooth sailing. I just got to teach you how to set them up, okay? And I'm going to show you some tips and tricks for that coming up. All right, so here we have a system, okay? And this system is great for substitution. Reason being, because the goal of substitution is we want to find a variable that was solved. Just like before, elimination had a goal where we wanted to find a variable that had the same number in front, one positive and one negative, okay? Because that way we can eliminate those when we add down. 3 plus a negative 3 is 0. Down here, what we want is we want a variable that's solved, where it says y equals such and such, or x equals such and such. So these systems, this system right here, this is ready to go because I know what y equals. So here, y is solved. Down here, x is solved. I know what x equals. X is equal to y minus 7. Now, not the normal kind of equals that we like, but nonetheless, we know what x equals. Okay, and we can use that. Over here, if you look at these, I don't have any y equals or x equals. In fact, I don't even have an equal sign on this one. I don't know why I don't have an equal sign there. That's not even an equation. So my fault on that. But again, either way, it's not solved. And then my equal sign should probably be right there. Okay. So just like before, if the goal is met, we start at step 2. If the goal is not met, we'll do step 1. Okay. Blue screen of death. Hate this blue screen. There we go. All right. So since our goal is met on this one, we're going to start here. And all it says is to sub the solved part into the other equation. So you see how you had y equals here? We're going to take this part and we're going to plug it right in for y. We're going to replace the y. We're going to put x plus 3. We're going to substitute it in. We're going to shove this piece right in there. Okay, whatever it takes to make you remember that, we're taking this and we're putting it in for the y. So the y variable is going to disappear, which makes this solvable because we'll only have x left. So if we go to our equation, we know what y is down here. That's y. So all we're going to do is we're going to take and we're going to put it right in there for y. Okay? We're replacing, we're substituting in, we're shoving it in. Okay? We're kicking the y out and putting the x piece in. All right? So step 2 looks like this. 5x plus 3. Oh, I see y. What is y? It's that entire piece right here. And I put this in parentheses just so you know it's a fraction. So that's negative 5/3 x minus 7 equal to 1. All I did was replace the y variable with what we knew it to be. Okay, and that's what I would have done on that 2.3 problem at the very end with elimination. Okay, I wouldn't have done elimination on that. I would have done substitution like this. Okay, so now we go back to our notes. Step 3 says solve for what's left. So now you've got this piece. All that's remaining is x. We can solve for that. So do whatever you need to do to solve. So we're going to go and we're going to take and we're going to distribute the 3 through the parenthesis first. And again, let your calculator help you out with fractions. There's nothing wrong with that. So we got 5x plus 3 times negative 5/3 gives us negative 5x. And 3 times negative 7 is negative 21 equal to 1. Okay? So over here you got plus a negative 5x. If you wanted to, you could just call this all minus if you really wanted to. Doesn't matter. You could have left it plus a negative. It's the same thing. So here we put like terms together. 5 minus 5 is 0. It cancels out. So all I'm left with is this. Well, we talked about this situation before, back in 2-3. So what happens when we have a number equal to a number and they are not the same? They are different. Well, hopefully you remember that this is a no solution. Okay? No solution. So in our little blanks, this is where, remember, D and E, comma, D and E. All right? And there you go. So that's, substitution in a nutshell. So go ahead, pause the video, give this one a shot, and go. All right. So in this one, we know exactly what x equals. So all we're going to do is take this part and put it right in there for x. So that gives us -2, parenthesis, -y plus 6, because that's what x is. And then we just finish the rest out. Plus 3y equal to 13. Okay? Step 2 says we solve. We didn't have to do step 4 on that one because everything canceled out. So if you have a special solution, it's going to happen here on step 3, which is the same thing that happened on step 3 up here. If you're going to have a special solution, it's actually going to happen here on step 2 to 3. When you add down, everything cancels out. Okay? So if you have a special solution, in step 3 is where this is going to happen, if your variables cancel out. So in this one, your variables do not cancel out. So you'll actually have an answer. We'll do step 4 in this. So -2 times a -y gives us 2y. -2 times 6 is -12. Plus 3y equal to 13. Okay, put like terms together. 2y, 3y is 5y minus 12 equal to 13. Okay, then we're going to add 12, add 12. So that gives us 5y equal to 25. Divide by 5, divide by 5, and you know that y is equal to 5. And just like before, you're making a point here. We don't know what x is, but we do know that y is 5. So this last step, this fourth step, is just like what we did in elimination. Plug the answer found into one of the original equations and solve for the last variable. Look at this. Plug answer found into one of the original equations and solve for last variable. It's the same thing. Okay? So all you're going to do here is take this 5 and plug it into one of these two. Again, it doesn't matter which one you plug into. I'm going to plug into the top. So that gives us x equal to -5 plus 6. What is -5 plus 6? X equals 1. And there we go. There's the answer. 1, 5. Okay? See? Not that hard. Not that crazy. All right. Now, this one. Do we have a variable solved? No. Okay? Well, that's no problem. So when the variable is not solved, we're going to do a step 1. Okay? Step 1 says, if the goal is not met, find a variable with a 1 or a -1 in front of it. And then we're going to solve for that variable. It's really easy to do this because if the number is 1, all you got to do is add or subtract the other variable to the other side. If the number is -1, you will add or subtract the variable to the other side, and then change all the signs to the opposites. Okay? So if it's a positive 1, just add or subtract the variable to the other side. If it's a negative 1, add or subtract the variable to the other side, and flip all the signs. That's it. So if I look up here, here is my variable that has the 1 in front. Okay? So that means all I'm going to do is take this 7x and move it to the other side. How do I get rid of a positive 7x? Subtract 7x. And now you know exactly what y equals. Y equals 1 minus 7x. Or you can call it negative 7x plus 1. It's your call. Now you know exactly what y equals. That's why I have you find the one with a 1 in front. Because if we choose something else that isn't a 1, you run the risk of making fractions and making this problem a whole lot more than what it has to be. So that's why I always look for a 1. Because as long as I choose the variable with the 1, I'm not going to have to worry about fractions. Again, just a side note, if this was 7x minus 1y equal to 1, again, my steps would be subtract the 7x, that doesn't change. So that gives us negative 1y equal to 1 minus 7x. And then the last step would be to flip all the signs, because what's going to happen is you're going to divide everybody by a negative 1. And if you divide by a negative 1, all that's doing is changing the signs. So that's why I don't say divide by negative 1. Even though that's what's happening, I just tell you, hey, once you get to this step, after you've done the adding and subtracting, flip all the signs. Okay? That's if it was a negative 1y there. Okay? No worries. All right. Now, whoops. Okay. Didn't want to erase. And so now that we know what y equals, you're right back to where we were. We're going to take this part and we're going to substitute it in to the other equation. Pause the video and go. Do it. Okay. So hopefully you found this information. So negative 5x plus 3 times 1 minus 7x, because that's what y equals 55. Okay, distribute through. So that's 3, positive 3 to be specific. And that will give us negative 21x equal to 55. And then we'll put the negative 5x in front. Combine like terms, negative 5x and negative 21 give us negative 26x plus 3 equal to 55. Subtract 3 minus 3, negative 26x equals 52. Divide by negative 26. Divide by negative 26. X equals, so just running my calculator real quick. That's what I thought. Negative 2. So now you know part of your answer. We know that X is negative 2. That should have been green, because we just solved for it. X is negative 2. But we're still missing the y value. So again, just jumping back up on my soapbox, I always go back into one of the originals. You can take this answer and plug it into this guy, but I would be careful, because sometimes, again, like I said, some of you have that math magic and you'll get through to this right answer, but there might be a mistake here, but somehow you magicked your way through it. But magic usually doesn't strike twice in the same problem. So this is why I always go back to one of the originals. Okay? So I'm just going to plug into the bottom one. And I think it's easier numbers. So 7 times -2 plus y equals 1. So that's a -14 plus y equals 1. So add 14 to both sides. And you now know that y is 15. And there is the answer. -2, 15. All right. Go ahead, try it on your own. I believe this is the last problem, I think. Might have one more after this. Let me double check. Yeah, one more after this, and we'll talk about that guy here in just a moment. All right, so go ahead and do this problem. Pause and go. Okay, so the variable to solve for is going to be this y value that's right down there. Notice it's negative this time, so you're going to get a chance to reverse all those signs. So all we have to do, how do I get rid of a -7/3 x? Add 7/3 x. So we now know that -1y equals 7/3 x plus 5. And as I told you in the last one, whenever you have that -1 there, you're really dividing everybody by a -1. But dividing by -1 is just the same as flipping all the signs. Now you know what y equals, and you can take and plug that in. So we're going to have 7x plus 3 times y, which is -7/3 x minus 5 equal to, close that parenthesis, of course, 4. There you go. And distribute. So that will give us 7x. 3 times a -7/3 gives us a -7x. I think you can already see what's kind of going to happen here. 3 times a -5 gives us -15 equal to 4. So if you combine like terms, those two cancel, leaving you with -15 equal to 4. And hopefully you said, this is a no solution, Mr. Armstrong. And I'd be like, yes, you are absolutely correct. Remember, if they were the same number, like -15 equals -15, that would be an infinite solution. OO, comma, OO. But since this is no solution, in your little blanks, you put D, N, E, comma, D, N, E. And there you go. Dunsies. All right, now let's talk about this one. So again, this happens in the land of substitution. This is in 2.4. This is a problem I would not do substitution on. Okay? Now that you know all three methods, it is fair game for any method. Okay? I would not do substitution on this, and I'm not going to do substitution on this because I want to talk to you about the pros and the cons to substitution, elimination, and graphing. Because when we get to the word problems, I want you to do whatever method is comfortable. But I will tell you, some methods are a little bit better than others. Okay. So, for instance, on this one, substitution is not my method of choice. Reason being, number one, I don't have a variable solved, and I don't have a 1 in front of any of my variables. So that would create fractions for me, okay? So, if the only time I use substitution is if I have a situation where the variable is automatically solved. If I have this, see, I know what x is. Or if I have this, see, I know what y is. That's when I use substitution. Other than that, I'm going to use elimination. I will rarely touch graphing. Okay. The reason why I don't touch graphing, because that's a lot of work in the calculator. You got to know how to manipulate quite a lot in the calculator. So I will rarely touch graphing. The only time I'll do graphing is if it actually wants me to produce a graph. If it doesn't want a graph, I'm sticking to elimination or substitution. Because again, graphing is very, very messy. Okay. And it's not as exact unless you have an actual graphing calculator and know how to work it. So graphing is my last resort. Okay. Most of the time, I start with elimination and I work my way from there. I look at elimination. Can I do elimination on this one? This is actually the easiest way to do it, is through elimination. Because I can pick my X value right here. I've already got a positive, I already got a negative, and I can turn them both into 4s. That's the easiest thing to do for this problem. I've already got a -4 on the bottom. I just need to make the top a +4, which means all I have to do is multiply this by 2. Okay? And if I multiply that all out by 2, you're going to notice, because the bottom stays the same, that when I do the add down for step 2, I get 0 equal to 0. This is so much faster than if I would have done substitution. You would be showing a whole heck of a lot more work. Okay? And 0 equal to 0, what does that mean for us? They're the same number. So remember, when we have a number equal to a number, and they're the same, I just talked about this. This is your infinite solution. Or in the parentheses, it's O, O, comma, O, O. Elimination is so much faster on this than doing substitution. Again, your homework, your quizzes, your exams, they're all on the computer. Is the computer going to know that you're supposed to use elimination or substitution on this? No. It's going to be written out in directions, but the computer doesn't know what you're doing. You're just typing in numbers for the computer. Okay? Will I know if you're using substitution, elimination, or graphing? Heck no. Okay? So you do you from here on out. So back into 2, into 3, into 4, use whatever method you're comfortable with. Okay? Because that's what's going to get you through. When it comes to word problems, you use whatever method you're comfortable with. Okay? Again, whenever I'm in standard form like this, I generally default to elimination. Elimination is great when you're in standard form. Substitution is usually when you have some sort of slope intercept, or again, you got a variable equals, x equals, y equals. This is in slope intercept form. So generally, if I have a slope intercept form, then I'm doing substitution. That's kind of like how I look at things. Graphing I stay away from unless it actually says I need a graph for this. Okay? Then I have to do graphing. All right, so those are kind of the pros and the cons for this, okay? So let's talk word problems. All right, the word problems in 2.3 and 2.4 that they're going to throw at you come in 2 forms, okay? Just like the word problems in chapter 1 for linear equations came at you in 2 forms. They either gave you 2 points or they gave you a slope and an intercept. Well, in system equations, they come at you in 2 forms. They're either giving you standard form, which I would use like elimination for, or they're translations, which generally in these tend to lend itself for substitution the most. Okay? So you're either getting standard form, where I would do elimination, or you've got a translation problem where most of the time you're doing substitution. Most of the time. Not all the time, though. All right. So how do I know the difference between these? Well, standard form. Here's what generally happens. In standard form, it gives you totals, and you'll have 2 of them. Like, for instance, I went out and bought a refrigerator and a blender for $100. That $100, that's a total. Okay? In my pocket, I have quarters and dimes, and I know that I have a total of 11 coins. That's a total, 11. I have a total of 11 coins in there. So when you have standard form, that means in your problem, you have two numbers that are generally totals. And it's also going to give you two ideas, okay, or objects. Like, for instance, in that first example, I said I bought a refrigerator and a blender. That's what I mean by it gives you two different ideas or objects. Refrigerator is one object, blender is another. The coins in my pocket that I have 11 of, I said that they were made up of quarters and dimes. Two objects, two ideas, quarters, dimes. Okay? So that's how you tell that you got standard form. You got two different ideas and you got two totals. Okay, so keep an eye out for things like that. And you know that standard form is written AX plus BY equal to C. Okay? AX, where X is your first item, plus BY, Y is the second item, equal to C, where C is what we call your total. Okay? All right. Over here in translations, just as it sounds, a translation means that they're going to give you mathematical words that you should be able to put into symbols. Couple things. So like if you see this, 2 times x plus 3. This is the kind of sentence that they would give you. This is a translation sentence because I can turn it into its mathematical symbols that you see right there. 2 times x, so whenever you have a number by a variable, that means multiplication, plus 3. Also know that whenever you see the word is, means equals. So if I said 2 times x plus 3 is 9, then this thing would be equal to 9 because is means equals. All right? So let's dive into these word problems. Now, I've got quite a few word problems here. I've got 1, 2, 3, 4, 5, 6 of them. I am not solving these. I am more concerned with, can you get them set up? Because if you can get them set up, then you can go through and do the solving. All right? I'm more worried about, can you get to the equations? Because if you can't get the equations, then you can't solve. Okay? Now, one of these I will do the solving on because it's a very important problem that generally you see quite a bit when it comes on quizzes and tests. All right, so moving on. So let's talk about our first problem. So in here it says, the Rogue Scholar has a benefit concert on Osceola campus. The admission fee for children is different from that of adults. Oh, look. It's already talking about children and adults. That's like two items. Let's see if we got standard form here. A group with 4 children and 2 adults pays $22. Okay. A family with 3 children and 1 adult pays $14. The question on this would be, how much are the children? How much are the adults? Do you know what's going on here? Is this a translation or is this a standard form? Hopefully you said that this is standard form. Reason being, pays 22. This right here is one of our totals. And down here, pays $14. This right there is a second total. So you now know one equation has to equal 22 and one equation has to equal 14. Okay? So with that being said, other thing that's generally cool about this, if you're generally doing standard form, each sentence represents an equation. So these two numbers right here go with this equation because this is about the first group. This right here is about a family. Okay? So the 3 and the 1 deal with the 14. So don't mix and match your numbers. Keep them together. Your equation should make sense in the end. And I'll show you what I mean by that here in a second. So if I was to write this equation for 22, this is what I would call it. And remember, it has to look like standard form. Standard form is ax plus by equal to c. You've already got the c in place. We just got to do the other pieces. So my ax part would be 4, and I'm going to call it c. Do not get me wrong. You can use x and y in here, but I'm going to use variables that let me know what I'm dealing with. So I'm going to call this 4c plus my by will be 2a. I can use x and y. There's nothing wrong with that. But the reason why I use c and a, because this variable is going to be about the children cost. And this variable is going to be about the adult cost. Okay? So I use those variables so I know exactly, once I get an answer for this variable, I know that, oh, that's about children. And once I get an answer for this, I know, oh, that's about adults. When I use x and y, then I have to go back and look at, well, what is the x really about? Okay? So by using variables that represent the item or the idea or the object, it's a little bit easier to deal with it in the end when it comes to those answers. Okay? Because one of your blanks will be children cost blank, adults cost blank, not x equals y equals. Okay? So this is why I use C and A. So what do you think the other equation looks like? You got it. 3c plus 1a. There are your two equations. Now we can solve the problem. Okay? And notice that 4c plus 2a equals 22, all dealt with the group. This is the group. And this right here is all about the family. 3 children and 1 adult equals 14. Okay? Now, in class, again, I wouldn't solve this, but we would talk about what method would you use on this? Would you do graphing, substitution, or elimination? Okay, so hopefully you would say elimination or graphing, or sorry, not graphing. No, stay away from graphing. Elimination or substitution, because you do have a variable with a 1 in front, but I think elimination is going to be your faster method, because I would get rid of the a and multiply this by a -2. I think elimination will be just a little bit faster than substitution in this. Okay? Other things when you do this, these problems should come out to nice, neat answers. There shouldn't be negative numbers. I should not have a negative answer for A and a negative answer for C, because that would just be plain weird. I can't pay negative. I mean, if you had a negative answer for C, that means these people are paying you to come see the concert. That's not how it works. Okay? If I got a negative answer for A, that means they're going to pay me to come see the concert. It doesn't work like that. Okay? They want to make money. You pay them, not the other way around. Other things just to watch out for. With money, you could probably have decimals. That would be okay. We generally don't have a lot of decimals in these. So if you have decimal answers, be cautious. Because generally we don't have decimal answers. They generally come out nice and neat. So those are some little tidbits for this. So if you actually did solve this and got an answer, know that they should be nice, neat answers. Positive and rarely, if ever, any decimals for the ones that we like to throw at you. All right. Moving on. Okay. So here it says, Hank took an algebra quiz or algebra test and quiz last week. He answered 15 questions correctly on the test and 3 questions correctly on the quiz. He earned a total of 63 points. Celine took the same test and quiz. She answered 14 questions on the test and 5 questions on the quiz correctly. She earned 61 points. So what do you think this is? Is this a translation or is this standard form? Okay, so those of you that said standard form, you're absolutely correct. Because again, you have totals. Hey, look, it even says total here. So this guy right there is a total. This one right there is a total. Go ahead and write me the 2 equations. Pause the video and let's see how well you did. Go. Okay. So hopefully right here, you knew that Hank and these 63 points are all about Hank. So all this information above here, this 15 and this 3, are all about what Hank did. Okay, notice you also have 2 items. It's all about questions on a test and questions on a quiz. Hey, that even fits what I told you about standard form. So if I did this, he did 15 questions correctly on the test, so I would probably call that 15T. Plus 3 questions correct on a quiz, so I call that 3Q. There's Hank's equation, because this is about Hank, this is about Hank, this is about Hank. Okay, just like before, that equation makes sense. This makes sense. This is about the group, about the group, about the group. This is about the family, the family, the family. See, these equations make sense. All right, hopefully the next one looks like this for you. And again, you can use X and Y, but I like to use the variables that are more descriptive. So this would be 14T plus 5Q. So there's your equations. That's what standard form looks like. Okay? And on this one, what do you think is the easiest method? Graphing, elimination, or substitution? Go. Okay, yeah, I would definitely use elimination on this one. 1, I don't have a variable that is solved. 2, I don't even have a 1 in front of any of these variables. Now, substitution would have been okay over here because you got a 1 in front of that A. But on this one, I would avoid substitution because that would introduce fractions for me. Elimination would be the way to go, and I would probably be dealing with the Q's, and I would make it a positive 15 on top and a negative 15 on the bottom. Okay? So you'd actually have to multiply both equations in this. If you want to see some of these worked out, please email me or come to a Zoom session, text me, call me, we can work things out and I can show you these being worked out. Again, my main concern is if you can't get to these equations, then you can't solve. That's why I want to make sure that you know how to get to the equations, because I think the solving you can do. I am confident in you on the solving. It's the writing the equations that scares me sometimes. All right. Pause the video. Give it a shot. After this, we'll be halfway through. All right. It says, for the spring dance concert, the Performing Arts Center PAC on East Campus sold 250 tickets to Valencia faculty and students and collected $1,610 in revenue. The tickets sold to the faculty cost $8 each, and the ones sold to students cost $5 each. So what do you think? Pause the video. Well, actually, no, you've already done that. Hopefully, when you were working through this, you saw this as a standard form. Okay? Just like everything else that was over here, just like the other two. These are all standard form. How do I know that? Again, I have totals. How many people came to the Performing Arts Center? 250. 250 tickets means 250 people. Okay? Tickets, people are the same thing. And then my other total is right here. They collected this amount of money. So I know that I have $1,610, and I have another equation equal to 250. I'm going to start with the $1,610, okay? Reason being, because if you look at these other numbers, this is about money. This is about money. And knowing what we talked about before, remember, this equation, all these numbers deal with the same thing. This is about a group, a group, a group. This is about a family, a family, a family. Over here, all these numbers, these are about Hank, Hank, and Hank. Celine, Celine, Celine. So when I go down here, this is about money. So whatever numbers I use over here better be about money. Okay? So I know that tickets sold to faculty costs $8. So I'm going to have 8F plus, and the one sold to students costs $5. 5S. See how this makes sense? $8, $5, $1,610. Money, money, money. Okay? Now, the other thing I want to tell you is about once you plug in these numbers, you no longer can use them. So if you're now looking up here, you're like, Mr. Armstrong, there are no more numbers left and I have to create another equation. And I'd be like, yes, thank you for pointing that out. You are absolutely correct. So how do we make this other equation? Simple, my friends. Whenever you run out of every number, your other equation is just going to be the two variables added together. F plus S. Now, does that make sense? Absolutely. Remember, what is F about? Faculty. These are people. What is S about? Students. Those are people. 250 is about tickets, which are all about people. People, people, people makes sense. Money, money, money makes sense. See, my equations make sense. So again, just kind of a rule of thumb, generally when you run out of numbers, your other standard form equation is just the two variables added together. Okay? That's why I wanted to start with the money one. So that way you can kind of see like, oh my gosh. Yes, he's right. I know I'm right. They pay me the big bucks for that piece. All right. So how would you have solved this? Well, I would do elimination. I think elimination would be faster because again, I'm in standard form, but there would, it's not bad to do substitution on this either. Okay. Because you actually have a 1 in front of the F and a 1 in front of the S, and you could solve for either one of those variables. Solve for F by subtracting the S to the other side, or solve for the S by subtracting the F to the other side. You could do substitution either way. But I think elimination, and I'd probably get rid of the faculty by multiplying this by a -8. And that would get rid of the faculty. Okay? There we go. All right. Let's talk about this one. Okay? We're almost done. We're getting there. I think we got 3 more after this. Yeah, absolutely. So reading this one, it says the sum of two numbers is 25. One number is 5 less than 2 times the other number. So reading this, is this standard form or translation? All right, so hopefully you said this is a translation. Reason being, I have mathematical words. Sum is less than times. All those are mathematical words. And again, kind of like what we dealt with before, how some of these sentences were each an equation. When it comes to a translation, one sentence is one equation. Okay, so this first sentence right here is your first equation. This second sentence is guaranteed to be the second equation. With translations, that's always true. Each sentence represents an equation for you. So if we look at this, it says the sum of two numbers is 25. All right. So because they're not really telling me the two numbers or anything like that, I'll probably just use X and Y. Okay. So the sum of two numbers is 25. Sum means to add. So this is X plus Y. Is means equals, and then 25. So you can see that in translation, sometimes you do get that standard form. Okay. Now, the next one says one number is. Pick one of your numbers. It doesn't really matter. Okay. You want the X or do you want the Y? It's your choice. Some people choose the Y, some people choose the X. I'm just going to say Y. Is means equals. Now, here's where you have to be extremely careful. Okay? This word, less than, super important. When you look at this, normally most of you are going to want to write this in order. 5 minus. This isn't the less than symbol, just so you know. Less than right here means subtraction. Most of you are going to write 5 minus 2 times the other number would be x, 2x. That's what you would want to write. However, this means everything is backwards. Everything that comes before the word less than is actually after the minus sign. Everything that comes after the word less than is actually before the minus sign. So it's not 5 minus 2x, it's 2x minus 5. So watch out for that word less than. Wink, wink, smile, smile, nudge, nudge, fireworks going in the air. You might see this somewhere on a quiz or test. Okay? So watch out for that. Everything is written backwards with the words less than. All right? And there's your 2 equations. What method would I use to solve this? Would I do graphing, substitution, or elimination? And I would definitely do substitution on this. I know what y equals, 2x minus 5. Take it and plug it into the other equation, and you're good to go. All right. So, pause the video. Give this one a shot. Okay. So, this one, hopefully you realize this is also a translation. It's more in context translation, but it is a translation. So, for instance, this first part is a little bit of, what we've talked about before. It takes 9 hours for Pascal and Regis to paint a few rooms. So this 9 is like an equals, a total, and then this is all about Pascal plus Regis. However long it takes Pascal plus however long it takes Regis, together it equals 9. Okay? So this is kind of like a translation in disguise. And this one down here is definitely a translation. It says it takes Pascal 3 more hours than Regis to paint the rooms. Be careful on this one. It says it takes Pascal 3 more hours than Regis to paint the rooms. Okay? So if you're thinking about this, up here, who does it take longer to paint? Pascal or Regis? Hopefully you said Pascal. And your equation needs to reflect that. Pascal is the one that takes the longest. 3 hours more than Regis, this more than means to add. Less than means to subtract, more than means to add. So this equation up here really does look like this, even though I know some of you are going to write it a different way. It should look like this. P equals 3 plus R. Because it takes Pascal 3 more hours than Regis. Some of you, what you will generally do is you will say R equals 3 plus P. Now, if you think about this equation right here means that Regis takes the longest because I'm taking Pascal plus 3. And from what we just talked about a moment ago, you guys told me that Pascal is the one that takes the longest. That's why this equation does not make any sense. Because in here, you're contradicting Pascal taking the longest. You're saying Regis is the longest. That's why the second equation looks like this. P equals 3 plus R. Okay? So there's your 2 equations. What method would you use? Graphing, substitution, or elimination? And I would definitely do substitution. Because I know what P equals. Plug it in the other equation, solve, and you're good to go. Okay? All right. Last problem. This is the one that in the end I will work out with you. I want you to pause the video and give this one a shot. I'm curious to see what you're going to do with this. And again, this is one that I'm going to work out with you in the end because wink, wink, nudge, nudge, smile, smile, fireworks in the air. You might see this again on a quiz or test. All right. Here we go. So pause the video and go. Okay. So, hopefully you know that this is standard form. You have 2 totals. You have 13,000 as one of your total. Your other total is $600. Okay. Now, so I've used those numbers. Just remember that we're not going to use them again. Now, up here, it says that you are investing funds into a 3% and 6% simple interest. Now, one thing on this, the first thing is, remember that you cannot put percentages into a problem the way they are. Remember, percents must be decimal versions. Percents, oh, it's writing weird on me, must be decimals. Okay? So what is 3% as a decimal? 0.03. What is 6% as a decimal? 0.06. Now the question is, do you know which equation those two numbers go for? Hopefully you said that they go into the 600. And I don't know why I have a decimal there. It's just 600, not 6,000. Reason being, these numbers are all about interest. What is the 600 about? Interest. That makes sense. Interest, interest, interest. So you're going to have 0.03, and you can call it X, or because this is called 3%, I'm going to call it T for 3. Okay? So there's the 3%, T, plus 0.06, and since this is 6%, I'm going to call that S. This equation makes sense. This is interest, this is interest, this is interest. Notice I've used all of my numbers. What does the other guy look like? Hopefully you remembered that this is T plus S. Remember, once you use all of your variables, or all of your numbers, the other guy has to be the two variables added together. Okay? And again, this makes sense. This is the money at 3%. This is the money at 6%. This is how much money you have total. Money, 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 interest, interest, interest. All right, now let's talk about solving this, because we haven't solved anything with decimals. So you can do one of two things. You can do substitution on this. Okay? That's fine. I'm going to do elimination. All right? And I want to show you how elimination works. Again, you could do substitution on this because you could either solve for T by subtracting S to the other side, or solve for S by subtracting T to the other side. Okay? So elimination, because that's what I'm going to do, I'm going to pick one of these two variables. I'm going to pick the T. Okay? So that means I want to get rid of the T, and I need to make them the same value. Well, the same value I'm going to make them, whatever this value is, that's what I'm going to turn the top into. So down here, I'm going to keep the bottom at 0.03. That means I need to make the top a negative 0.03. So what am I going to multiply the number 1 by to make it a negative 0.03? A negative 0.03. Okay? So up top, we know that is already happening for T. Negative 0.03 times S is negative 0.03 S equal to 13,000 times 0.03 negative is negative 390. The bottom equation still stays the same. Okay. So all we have to do now is just add down. So T goes away. This will give us 0.03 S equal to 210 divide by 0.03. So S is equal to 7,000. So we invested $7,000 at 6%. See why I use those variables that let me know what I'm dealing with. If I used X and Y here, I'd probably have to go up and look, okay, what did the Y really represent here? Okay. So use descriptive variables when you can. All right. Then all I'm going to do now is take what I know here and plug it back into one of my originals. And I'm going to plug it into the top one because that's the easiest to work with. So T plus 7,000 equals 13,000. Subtract 7,000. And you end up with 6,000. So that means at 3%, we invested 6,000. And again, with all of these answers, I don't know why I added an extra 0 there. With all these answers, you can always check them. Just like what I've told you back in the elimination and graphing, I think I mentioned it in there. I could take these answers, plug them in for S and T up here, and see that they work in both of these equations. Okay? So I wanted to make sure I touched base with that one because you might see this again. Okay? And that, my friends, is substitution, elimination, and graphing. Thanks for stopping by.